Okay, in this video we're going to develop the formulas for a sum of a geometric sequence. We're going to take the sum of n terms of a geometric sequence where the first term is a sub 1 and the r is our common ratio. So here's our sum written out in long form. The first one's a sub 1, second one's a sub 1 times r, the third one is a sub 1 times r squared. We found this to be true in our previous video, and this is the formula for the nth term of our sequence. This is our formula for a sub n. Here's a sub n right down here. Okay, so what we're going to do to develop this formula is take r, we're going to take r times this and write a sub 1r plus a sub 1r squared plus a sub 1r cubed plus, and then the last one's going to be a sub 1 r to the nth power, because we added 1 to that and it's 1 more than that. Now what we're going to do is subtract these two things. We're going to subtract. This is going to develop the formula that we're going to use. You're not going to need to know how to do this, but you're going to need to know, I'm just showing you how we develop the formula. So our formula is going to be s sub n minus r times s sub n. And then when we subtract, these terms are going to drop out. We're going to drop out all of these terms. All these terms are going to drop all the way out until we get down to here. So we're going to only end up with the first term plus the last term on this one right here, a sub 1 r to the n. We're only going to end up with two terms left over when we subtract. So we got rid of a bunch of terms because they were the same in both sequences. This allows us to solve for the formula. Now we would want to factor on both sides. So we factor out, you factor out the s sub n on this side. So it's going to be s sub n parentheses 1 minus r. And on this side over here you're going to factor out the a sub 1. And that's going to be 1 plus r to the nth power on that side. And then what we would do is we would just divide by 1 minus r. So we're going to get s sub n, that's the sum, it's going to be a sub 1 over 1 plus r to the nth power over 1 minus r. And that's the formula for the sum of n terms of a sequence, where n is which term. Okay, now my example here, it says find the sum of the first 8 terms of the sequence. So let's first of all determine what some of the values of the sequence are in this example. So my first term, n is 1, we're going to put 1 in there. That's going to be 1/2, so it'd be 5 times 1/2, or 5 halves for n is 1. N is 2, that's going to be 1/4, so the next term is going to be 5 times 1/4, which is 5/4. And the third term is 5 times 1/8, because that's third power, so that's going to be 5/8. Okay, and we can check to see if this is a geometric one. We do 5/4 divided by 5 halves, and we get 5/4 times 2/5, and we're going to get 1/2 here. And so it looks like we're going to be, if we do the next term, 5/8 divided by 5/4, we get a similar outcome. 5/8 times 4/5, cross out the 5, so we're going to get 1/2 again. So my ratio here is 1/2, and my first term is 5 halves. So if I use the formula that I have here with the 5 halves and the 1/2 as my ratio, my formula up above is s sub n, so s sub 8 equals a sub 1. A sub 1 is 5 halves times 1 plus r sub n, so r sub n is 1/2 to the 8th power over 1 minus r, I believe is our denominator, 1 minus r. So 1 minus r is 1 minus 1/2. We're going to get approximations for this because that's That's a large decimal for 1/2 to the 8th power. So we're going to put it in. So 5/2, I know what that is in a decimal. That's 2.5. So I'm going to write in 2.5 times 1 plus 1/2 raised to the 8th power. Okay, so I have one parentheses there. I'm going to need one more, divided by my denominator, which is 1/2. Okay, my answer is 5.019. So my answer approximately is 5.019. 5.0195. It's my answer to 4 decimal places, approximately, for this formula. Alright, now I'm going to use this to do the same thing, but I'm going to use the formula in generic terms. So I'm not going to have the n value here for this sequence because I want to find the nth term. So when I'm finding the nth term, this is going to stay n. We're going to fill in everything else. So my a sub 1, let's figure out what a sub 1 is here, and my r. Now in this formula I can see r right here is 3 because it's the one with the exponent on it. But let's figure out what a sub 1 is. So that's going to be 2 times 3 to the 1 minus 1 here. So that's 0 power, and 3 to the 0 power is 1. So my first term is 2. Now we can check to see what our ratio is by doing the second term, but our ratio is going to be 3 because that's the exponent, or that's the base of the exponent here. But let's plug it in and just make sure. So a sub 2 is 2 times 3 to the 2 minus 1, which is a sub 2 is 6. So if I divide those two terms to get r, it'd be 6 divided by 2, which is 3. So r is still 3. So in writing the formula, I know a sub 1 is 2. I know r is 3. And I know what r is down here also. It's 3. So my s sub n term is going to be negative 1 times 1 plus 3 to the nth power. Okay, if I simplify this, this is going to be negative 2 on the bottom. And we're going to reduce that term in front. So we reduce this part of it and we get negative 1. This is my solution to s sub n, or my sum of n terms in this sequence. This is my formula. Alright, now my final thing in this example is sometimes we add up things infinitely. If we have an infinite thing, what we have is we have a converging sequence, or converging sum. That means that it gets closer and closer to an approximate value, and this is the formula for that approximation. So as we get closer and closer, now that only occurs when our ratio is less than, or the absolute value of the ratio is less than 1. Then we can take an infinite sum. We can add up all the numbers we possibly can in the sequence, and we're going to get close to this value right here. So in this case, I'm going to show you one example. This one here, we're adding things up. Our ratio here is 5 divided by 10, which is 1/2. And we can double check that if we take the next term. 5/2 divided by 5 is 5/2 times 1/5. And we would reduce, and we get 1/2 again. So our ratio is 1/2, which is meeting this criteria, that's less than 1. So we can actually find the sum of all of these. We don't have to stop at the 8th term. We can continually add these up, and it's going to get close to a certain number. Now if r is not less than 1, or its absolute value is not less than 1, then we can't have a sum that converges. It will diverge, which means it just gets bigger and bigger, and it will never approach a value. So in this case, we have a convergent sum. So we can use the formula. We know what a sub 1 is. That's this value right here. This is a sub 1 right there. So we have 10 over 1 minus 1/2. So this is going to be 10 over 1/2. which is 10 times 2 over 1, which is 20. So what we're saying here is if we add all these terms up, keep adding these terms up, we're going to get closer and closer to 20. 20 is going to be my final answer. If I get tired of adding, we're going to get really, really close to 20. We'd round it up to that anyway, because it's going to be so close by the time we get to the 50th term here. And we could try that out. We could try out, well, let's find out what s sub 50 here is. Just to verify that this works, we can use that formula, right? 1 plus r to the n over 1 minus r. Let's use this formula. See how close we are. We're going to add up the first 50 terms and see how close we are to this. So it's going to be 10 times 1 plus 1/2 to the 50th power over 1 minus 1/2. Okay, so most of this is already in here. We can just clear this out and type this in again. So we're going to go 10 times 1 plus 1/2 to the 50th power. Okay, so if we do that, that's our numerator. We're going to get 10, and so even my calculator, when divided by 1/2, even my calculator thinks it's 20. So at the 50th power, it's saying it's still 20 because we have such a small amount here that it's going to give us, this is going to be so close to 1. 1/2 to the 50 power is so close to 0 that we're just going to get 1 here. So this is going to be approximately 20. Just to even do the formula with 50th power, we get 20. So we used such a big number here that it actually was very close to the same number. But if we used, like if we just look at the first two terms, that's just 15. So that's not going to work for s sub 2. But as we get bigger and bigger, it approaches a value, and that only works if r is less than 1. Otherwise, we're going to have to use the formula for how many terms we want. If we want 8, then s sub n is going to be s sub 8, and this is our formula that you want to use for the s's for that. Alright, so that's our final video on geometric sums and sequences.